4 is a pretty good problem too, by the way. So let's make sure we do that. Okay, so 4, Babette stands at the top of a hill with a toboggan that has no brakes. She is 203 meters from a pile of snow. Babette reaches the snow 50 seconds later after she starts down the hill. If she makes a 2-meter dent in the snow pile, what acceleration is provided by the snow pile? So I know I got at least 2 accelerations. I got acceleration for the hill, which is what? Am I falling? I don't know. That's really rude. Oh, and then the other, I got acceleration for the snow, which is what? Oh man, I gave you nothing. Okay, so now we go back to the first part and we go. So I'm gonna look at the second part here. Second part, I've got a snow slams into it. If I make a 2-meter dent, so my displacement's going to be 2 meters. Agreed? Miss Maddie, with me? Okay. How? Do I know anything else about the final part?
The initial velocity there is going to be the
Final velocity here. Do we know the final velocity here? So we don't know that yet. Do we know? We don't know the acceleration. We already established that. We know. Do we know what the final velocity is, though? Do we know that?
0.
0. So final velocity is 0. So I have that. But I'm looking really dire over here, isn't it? I mean, I could go ahead and start doing my 2 equations. D equals 1/2 AT squared plus B naught T, and I can go V equals B naught plus AT. The final displacement's 2. 1/2. Don't know what the acceleration is. Don't know what the time is. Do I know what the time is? No, I don't. Initial velocity, I don't know, and time, I don't know. So I'm pretty much in a pickle here that I'm not going to be able to get out of. At least until I have the initial velocity here, which means I need the final velocity over here, correct? What Mario just said. So I'd set up the final velocity equation. Go V equals V naught plus AT. Final velocity, don't know. Initial velocity, Mario.
0.
0. Acceleration. Time.
50 seconds.
50 seconds. So at least have that. If I had the acceleration, I'd be good to go. Don't have that. But I do know about the displacement. It's going to be displaced how far during this stretch?
203 meters.
203 meters. So let's try the displacement equation and hope against hope that this mess is going to get better. So you said displacement's 2. Oh. Okay. Displacement's 203. 1/2. What's acceleration? No. Times 50 squared. What's initial velocity?
0.
0. So that goes away. So I can solve for the acceleration, correct? So 406 equals 2500A. 406 divided by 2500, give myself a good approximation. A equals 0.1624. Didn't ask me for that though. What it asked me for is the what is the final velocity here, right? I'm gonna plunk that back in here. Figure out my final velocity is final velocity.
0.
Well, we found the acceleration, right?
Yeah.
Plug it back into this equation, find my final velocity. When you got it, let me know. Don't have a calculator. .12. So now I know that my final velocity is 8.12. I can try to solve these things, right? Because that's the initial velocity over here. So I'm going to go 2 equals 1/2 AT squared plus 8.12 times T. 0 equals 8.12 plus AT. Where to go from here, Matteo?
Wait, how do you know it's 0? The velocity's like
Because
0.
what happens at the end of a run, how fast is he going?
0.
If he makes a 2-meter hole, that means he stopped, right?
Oh.
So you guys think
What's next? Just go ahead and get caught up. Get yourself all set up, and then look at it and say, tell me what will you do next. If you don't know, we'll just figure it out.
you can either solve for A or T. You don't want to solve for T. So you solve for A.
So isolate A. Just once, I should probably show you what happens when you isolate for T. Sometimes it works out okay. Sometimes it's really, really bad. Is Sax okay? Plug that in over here. Bring it back. Wait, how deep a hole does he make? 2 meters? Math seems bad. Oh, I evolved a number. That's the problem right there. That should be a 2, right? Thank you. I'm like, yeah, it shouldn't take him 3 seconds to stop if he's only going 2 meters. All right, so let's try this again. 2 divided by 4.06. There's a reasonable amount of time. 0.493. So I take that, move it over here. Find the acceleration. About negative 16.5 meters per second squared. I think that's 1% of our whole school walking down the hallway today. Good? You can do 4. What? Should we move forward or put some glasses on?
But how did you? Wait a minute. 8.1. What did you do with 8.1t? The plus 8.1t.
Right here? Oh, this step here?
Yeah.
Okay. If you take this t,
yeah,
you're going to get negative 4.06t plus 8.12t. Agreed?
Oh, that's cheap.
But the t's cancel out, and then it's half of 8.12, which is 4.06. Negative 4.06 plus 8.12. Add those up, you get 4.06t. Okay? Feeling groovy? How about 5? Do we do 5, or is the lame 5 good enough?
It's up there.
It's up there on the left in
Valid.
chicken scratch. See if you can identify which one was written by a boy. Which two panels were written by a boy? Yeah, did you get an answer?
Not getting an answer.
Exactly so. Flat. The acceleration due to gravity is unknown. To test it, Spiff puts his body on an air compressor and then launches himself with acceleration of 23 meters per second squared. For the 4 meters, he is on the air compressor. If he lands 3 seconds later, it's in the ground because it says he leaves at ground level. So assume at ground level, he's got to be underground, right? It pushes him up. He lands 3 seconds after he leaves the ground. What is the acceleration of gravity on this planet? Alrighty then. How do I do this problem? We have it broken into 2 pieces. I have air compressor, and that's 23 meters per second squared. And then on the other side, I have what? Auger? Acceleration to gravity, correct?
Yeah.
All right.
We don't know.
We don't know what it is, right? So it's unknown
What's the one right?
because I got 2 different places where I have 2 different accelerations, right?
Did you get 13.5 seconds?
I didn't get an answer. I can't figure out how to solve for acceleration or distance.
You got 5.589 seconds there a second. Okay, so what are we gonna do here? So we're gonna do the last part first because hopefully that'll just give us an answer. We're gonna go v equals v naught plus at. Final velocity is not when I hit the ground. It's not. And then after that, the ground decelerated me. That'd be a third acceleration. I don't want to deal with that. So his final velocity is I don't know. Right? The moment he hits the ground, he's moving, right? Because he stopped. He's in the snow. What happens when you run into a snowbank? What's your final velocity when you're done running into a snowbank? Okay, but we included the snowbank in the last one, didn't we? Do you want to consider acceleration of ground, right?
Okay.
Yeah. I don't want to do that because I know nothing about that. I hope it doesn't even matter. It might matter. We may have to do it, but let's not talk about that just yet.
So Raven told us that his floor makes a little dent in the ground.
He would make a little dent. If I told you he makes a 0.2 meter dent in the ground, we'd be over here, wouldn't we? Because we know final velocity there.
If you tell us he doesn't make a dent, can you assume final velocity is
You always make a dent when you hit the ground. It may be microscopic. And when I'm walking around, I'm making dents in the ground right now, no jokes. Right now, I'm making dents in the ground because the ground has to stop me. Right? And you can see that when you're walking on a trampoline. You're on a trampoline, you can
It's
see
no
the dents.
empty space anyway, so it doesn't matter.
What? Oh, like sand. You have to make a dent to stop, right? So those dents are only visible. We're not walking around on concrete or tiles or something, right? But they're still there. If you were to take a microscope and watch somebody stepping on the ground, they actually bend the tiles underneath them. Even somebody as little as, who's the little person in the room now? We'll just say the girls in this room. Okay, good? All right, so the recording's going to kick out and they don't get to watch anything else. That'll be good. I should probably just pause it and start the next recording. All right, whatever.
Oh, they're hearing this right now?
Well, I'm trying to record it. Let me go ahead and